Hi guys, welcome to the first day of the PaloAlto class. So today is the day 1. So today we are going to study about the PaloAlto basics to advanced version. So since this is the day 1, we are just going to cover the basics of the PaloAlto firewall, where it is developed and who developed it, and we are just going to study about all the basic features of the firewall. So now let's start. So PaloAlto is the name of the firewall. You can see it is also the company's name, PaloAlto. So this is derived from the San Francisco in California, and it is in USA. So it was developed by an Israeli American, and his name is called as Nir Zuk. Okay, so he is the former engineer of Checkpoint, as well as he is the former engineer of NetScreen Technologies. Okay, so this PaloAlto firewall is also called as next generation firewall, NGFW. So why we call it as a next generation firewall? So it all because of the three features called app ID, and another one is user ID, and another one is called as content ID. So let's see one by one how this next generation firewall differs from the non next generation firewalls. So when the PaloAlto was introduced in 2005, so already we have Cisco ASA in the market, and also we have Checkpoint, and also we have Fortinet. So we have all these firewalls. So what all these firewalls were doing? Initially they were doing stateful, right? Stateful. It is innovated by Checkpoint. So initially there were no stateful firewalls, all were stateless firewalls. When the Checkpoint came, it introduced stateful. Then all the Cisco ASA, Fortinet and other firewalls, they just followed the stateful firewall concept. And now we know that we got PaloAlto firewall. PaloAlto firewall is the next generation firewall which introduced app ID. It innovated app ID. What it means app ID? Why the PaloAlto firewall took over the market by storm? Because already we have next generation firewalls. No, we don't have the next generation firewalls. Already we have firewalls which can able to block the packets and mitigate some of the attacks, and they can do all the firewall functionalities. Okay, we will study all those things one by one. Okay, now what happens? Already we have Cisco ASA, right? Cisco ASA is the market leader in olden days, and suddenly Checkpoint came and it took over the market because it was using stateful as the concept. It introduced that particular concept. Now when the PaloAlto came, it just introduced the concept called app ID, and it took the entire market by storm again. Now PaloAlto firewall is the number one firewall. Okay, so most of the companies are using PaloAlto because of this app ID. Now let's see what is called as app ID and how it differentiates itself from the old firewall. So in the old firewalls, not old, in the previous firewalls like Cisco ASA and Checkpoint and Fortinet and all of the rest of the firewalls, so they used to block the traffic based on the source IP address, and also they used to categorize based on the destination IP address, and they used to categorize based on the source port and destination port So they use these 4 categories, right, to block the particular traffic. So for example, we are going to block a particular website. For example, take Facebook. In this case, what we do in this Cisco ASA checkpoint and Fortinet firewalls, we just go and block the destination port 80 or 443, because this Facebook is working on HTTP, right? HTTP or HTTPS. So that's why what we are doing, we are blocking it on these particular ports. So now what happens when we block this particular port for this particular source and destination? What happens? The entire HTTP traffic will be blocked. So what we need is, we need to just block the Facebook, or we need to just block the chat option, or we have something called gaming. So there is an option to play games in Facebook. So we just need to block this particular module in the Facebook. Previously we cannot do it. We have to block entire Facebook to block this particular thing. So now what happened in PaloAlto firewall, they introduced something called app ID. So app ID means application ID. So what this application ID does, so example, take you are viewing facebook.com and you are also browsing something xbox.com in your browser. So what this firewall does, it just categorizes it based on some of the decoders. And it has some application signatures. So what this firewall does is, it categorizes this Facebook website using some kind of signatures and decoders, and what it identifies is, it just differentiates all the modules within the facebook.com. Means for example, it can identify the particular chat feature, so we can block the particular chat, and we can also block the games feature, and we can also block some of the features, like we cannot post anything in the Facebook. So all these kind of things we can do it in Facebook with the help of the application ID, that too in the PaloAlto firewall. So this is what the PaloAlto firewall does. It uses app ID instead of the particular port numbers. So currently PaloAlto has more than some 300 application identifiers, means it can identify the different internet application using these signatures. So now all the firewalls like Cisco, Fortinet, so now we have all the firewalls like Cisco, ASA, Fortinet, and what else we have, Checkpoint. They all followed the same concept. Okay, now they have introduced something called app ID. So all the firewalls have this app ID features right now. So now even Cisco ASA has some 3000 kind of application identifiers or signatures, because Cisco, it already has something called NBAR, network for application identification. Okay, it's something called as application network based application recognition. So what it does is, it identifies what kind of application is running in the routers. So this NBAR is used in QoS, quality of service, in Cisco routers. So but what happens is Cisco missed the opportunity to claim that they what so so each company has done its innovation. So Cisco missed this particular opportunity since they already have the NBOR feature within them, because NBOR is application decoder which can identify applications and apply the QoS based on the particular application, particular signature. But they have not introduced this NBOR feature in the firewall. If they have introduced, now Cisco will be a market leader in the firewall. So application ID will become, so it must have already done, so some 10 to 15 years before already we have NBOR, before NGF, before this PaloAlto. Okay. So now we understood that the difference between the other firewalls and the PaloAlto firewall. Now all the firewalls is having the same features. Okay. So now let's understand about the packet flow. Now let's understand about the packet flow. So packet flow in PaloAlto firewall. So different firewalls has different packet flow. So right now we are just dealing about the PaloAlto firewall. Now let's understand what it is. So the first thing in the packet flow of the PaloAlto is ingress. Sorry, it's ingress stage. So this is the first stage. So what happens in this ingress stage is, so imagine our packet just arrived at the firewall's front door. Okay, this is the firewall. So someone is sending the packet. So this is the packet. So it is coming to the front door. Okay, this is where the firewall first grabs the packet from the network cable. Okay, it's like a bouncer at the club doing a quick initial check to see if this packet even deserves to be here, because firewall just will not allow all the packets. So whatever the packet comes, it can either allow or it can either deny based on the initial check itself. Instead of going through the rest of the checks, it can either accept or deny in the initial stage, because it can save a lot of resources by doing this. Okay, so what happens, sometimes the packets are just badly formed, they just don't follow the network rules. The firewall drops them right away, so it's a waste of time to process the broken stuff. So some attacks are so obvious and it's bad that the firewall instantly recognizes them and drop the packets. Okay, so these are attacks that even the end devices would not accept anyway. The firewall stops them efficiently. Okay, so whenever you receive a packet, the firewall can drop. So how it drops? It checks using the L2 and L3. So it uses the first L2 and L3, something called as parsing. Parsing means nothing but opening of the packets. So it just opened the layer 2 and the layer 3 headers. It opened the headers, right? The first thing the firewall does is it opens the packet to look at the ID card. For example, take a bouncer, someone, he's just sitting in front of the, or he's standing in front of the some shows. So he want to make sure that only the eligible person is allowed inside this particular venue, because no other person should be allowed. So a bouncer will be waiting outside and he will be checking our ID cards, right? So similarly, what a firewall does, it just passes the layer 2 packet as well as the layer 3 packet. Okay, what it does, what it looks in the layer 3 or layer 2 packet, So first it checks if it is a layer 2 packet. What it does is it checks the source MAC. It also checks the destination MAC, correct? And also it also figures out which network port the packet came on, and if there is any VLAN tags. And it also uses this to find the correct logical interface to where it belongs. Okay, if it can't match it up, what happens? Our packet is immediately discarded, and the firewall quietly updates the error encounter. Okay, so error counter. So we would not want to log every single packet, right? So L3. So now let's see about the L3 packet. So now the L2 packet passing is done if it is a L2. Now if the interface is L2, if the interface is L3, it has to do the L3 packet passing. So now we deep dive and look at the IP header, and here in the IP header it checks the source IP and the destination IP. At this point the firewall is looking for some serious red flags. Means, for example, if the Ethernet frame says it's IP but the IP version doesn't match, or the time to live is 0. It also catches the old school attacks like land attack or ping of death, right? And if anything suspicious is found, the packet is discarded. So after L3 passing, what we do? We go for the L4 passing. So L4 lookup. In L4 passing, what we do? We does the passing of TCP and UDP. Also we inspect ESP in this, because if IPsec tunnels are there, we inspect the ESP, and we also inspect the GRE, and we also inspect the ICMP headers. Okay, and sometimes what happens, we also, so previously what we have done L2, L3 and L4 parsing. Now in the ingress, what it checks for the IP fragment. Okay, reassembly. So IP fragment reassembly means, so consider the source and the destination. When the source is sending the packet, if it is greater than 1500 bytes, so this is the firewall. So if it is 1500 bytes, what the client does, if it is more than 1500, for example, take if it is a 5 MB file, and this client can only transfer a maximum of 1500 bytes, because the MTU, maximum transmission unit, is 1500. So now we want to send 5 MB of data. So what we have to do, we have to just fragment all the packets, right? So we have to fragment into three parts. A single now what happens, a single file is divided into 3 parts. The 5 MB file is divided into 3 parts, 1.5, 1.5, 1.5, and it is sent over the firewall. So once the firewall receives, it transfers the packet to the server. What the server does, it does the reassembly of the packet. Okay, so the firewall checks whether the fragmentation and reassembly is as per the protocol standards. It should not expect any, it is not expecting any anomalies, right? Anomaly means from the standard process it should not deviate. If it is deviating, what it does, the firewall just blocks the packet. Okay, So the third is ingress processing error. Ingress processing means if something wrong happens. For example, during the initial entrance checks, so a packet is coming to the firewall. So this is the firewall, a packet is coming here. The firewall encounters a unrecoverable error. The packet is simply discarded. So it's a general bucket for anything that fundamentally breaks protocol during the ingress process. Okay. And the next check, what it does is it checks for DOS block. DOS block table. Okay. So the firewall, what happens, it keeps a special list of IP addresses that are behaving badly. Okay, especially when it comes to denial of service attacks. So before doing anything else, it quickly checks if the packet source IP address is on the block table. Okay, because if someone is hitting the firewall, so I have to check whether they are doing any DOS attacks, any kind of DOS attacks, because previously I have encountered DOS attack. So I have some list in the DOS block table. So I have to match whether this particular source address is on the block table. If it is, then the packet is immediately dropped. Okay, this is the super fast way to stop unknown attackers from flooding your network. Okay. So, and the other thing is another fifth type is tunnel decapsulation. So what happens, sometimes our packet comes wrapped inside another packet, like a letter inside a letter. This is called tunneling. Okay, tunneling, or sometimes they used to call it as encapsulation in technical terms, and is often used in VPNs like IPsec VPN and SSL VPN or GRE VPN or SSH connections. So all this does similar kind of thing. So if it is a IPsec packet, so the firewall receives the IPsec packet. So what it does, it validates the hash first, and then it decrypts the contents of the packet, correct? So whatever packet it gets, it has to decrypt it, and finally it has to decapsulate. And if it is SSL VPN, so what happens if it is SSL VPN? It is also similar to IPsec. It validates the hash first, then it checks for the decryption, then it decapsulates the packet. Okay, and GRE also same. For GRE, we are not doing any encryption, so it is a plain text. So what here we are doing, we are just doing the hashing, and we are doing decapsulation. Okay, we are not decrypting, because GRE we are not protecting, we are not using any security protocols for sending and receiving. And finally SSH. SSH, a hash check and the decryption is performed on the SSH. Okay, so if there are any errors during this unwrapping, the packet is discarded. So once unwrapped, the firewall assigns a new ingress interface, which is the virtual tunnel interface to the packet, and then what it does, it sends the packet all the way back to the beginning of the parsing stage. It's like finding a new letter inside the envelope and realizing that you are going to read its address properly. So after decapsulation, the PaloAlto always starts passing with the IP header, regardless of what the original outer tunnel was. Okay. So now we have completed the ingress. Now the second thing, the main second thing what we are going to look now is flow lookup. So flow lookup means it's like how we met before. Uh, uh, so consider this is the firewall. So someone is initiating a connection, a client is initiating a connection to the server. So I need to check, this firewall needs to make sure whether this is existing flow or this is a new flow. Okay, someone is coming newly to the firewall, or they have already met, okay, or existing connection. So the firewall needs to make sure. So in flow lookup, what happens? Our packet has already passed the initial entrance examinations. Okay, now the ingress stage has been passed. Now the firewall asks for the crucial question. What kind of question it asks? Is this a packet part of the existing conversation? Okay, this is whether the existing connection. Okay, so every single connection that goes through the firewall creates a session. So this session has two parts. One is client to server session and another one is server to client session. So yesterday we have seen this. So consider this is a firewall. Okay, this is the client and this is the server. So when I am initiating a session, this is called as client to server session, and when the server is initiating something, some connection, this is called server to client session. Okay, so when you check the logs, you can able to see that you are getting two kind of logs. One is from C2S and another one is from S2C. We will just check all this during when we are doing some practicals. Okay. So each of these, so each of the client to server and server to is identified by 6 tuple. They called as 6 tuples. So the first is the source IP, another one is destination IP, another one is source port and destination port. Apart from that, what else it will be looking for? It will be looking for the zones. It will be looking for the security zones. Okay, whether it's a inside zone or outside zone, because usually if it is a firewall, so consider this is a firewall. If it has 3 interfaces, some companies will choose all the 3 interfaces for doing the connection, for connecting. So for example, they will consider this as 1. Consider this is fast as 0/1, 0/1, and this is fast as 0/2, and this is fast as 0/3. So they will make this as inside interface, inside, and this will make they will make this as outside interface, and they will make another interface as DMZ. It all depends upon the network requirements of the company. So if the company thinks they want more kind of interfaces, they can go for sub interfaces also. But if a company thinks they just want to configure the firewall as L2, they can do it. So they can do all the configurations. Okay, so what happens, the firewall does, the firewall keep track of all the active sessions. So when a new packet arrives, it quickly pulls the 6 tuples and check if it is matches the existing session. Okay, If it is not there, it drops the connection. If it is not there, whether it will drop? No, it will go for a new session. It will go through a new session. If existing session is there, what happens? It will refer the session table and it will easily match the session table and it will allow the session easily. Okay. So for every conversation you will have a C2S and S2C. So all the packets for each direction must stick to their uniqueness. Okay. If the packet matches the existing connection, it jumps to the fast path. If it's completely a new conversation, like already we said, it has to go through the slow path. So far what we have seen just the ingress and the flow lookup. So to revamp, what the ingress does, it will just check for the protocol anomalies in the ingress, like L2 parsing, L3 parsing, L4 parsing. It will do everything, and if something anomaly is found in the protocol headers, so it will block there itself. So what happens if there is no anomaly? Then it will go through the flow lookup. In the flow lookup, what happens? It will check for two kind of flows. If it is an existing flow or it is a new flow. If it is an existing flow, it has to go through a fast path. If it is a new connection, it has to go through the slow path. Okay. So now we have studied about these two. Now we are going to study about the third one, which is slow path. Now the flow, as this particular flow lookup has identified the session as a new conversation. So new conversation means it has to go through the slow path. So now we are going to study about the slow path, what kind of actions the firewall does in the slow path. Yeah. So in slow path, so our packet has just started a brand new conversation. So the firewall needs to know or do a lot more work inside its hardware. This is where it really digs deep before creating a session. So don't worry, slow is just a relative word. The firewalls are incredibly very faster. Okay. Slow path means it's just a canonical term to just mention what the firewall does in the slow path. Okay. So first, what in the slow path, it does a zone protection checkup. Okay, zone protection profile. Okay, we have different kind of profiles in the firewall. The first check what it does is zone protection profile. So in this, what it checks, the firewall checks if the incoming network zone has any special protection rules. Okay, these rules are designated to stop various flood attacks like SYN attack, UDP attack, and ICMP attack is there, and some port scanning attempts will be done using the Nmap, and some IP spoofings will be done. So all these kind of attacks will be checked against this zone protection profile. Okay, and if the zone protection profile found any kind of attack is performed in the firewall, it will straight away block the traffic. Okay. And the second is TCP state check. In the TCP state check, the firewall wants to make sure that things are happening in the correct order. So okay, a TCP connection must have what it should have. A TCP connection should have a SYN packet. So the initial packets should always be SYN to the firewall. Okay. If it is not a SYN packet, or if it is a different packet other than SYN plus ACK, the first packet should always be a SYN packet, correct? This is the correct order. If it is a SYN plus ACK packet, if the first packet is SYN plus ACK, what it means? Something fishy is happening. So the firewall, what it does, it drops the packet. So this is the TCP state check. Okay. So this is also called as stateful inspection. So it is generally a good security practice, but sometimes what happens in complex networks with usual routing, you might need to adjust this behavior. Okay. So we can manipulate this TCP state check. We have a separate command for it. We will just go through the command later on, or I will send you the command in a separate document. Okay. So on the third thing, what it does is, that third check is IP to user mapping. IP to user mapping catch. It checks IP to user mapping catch. So it just check who is this particular user. So this is the firewall. If someone is hitting, consider a user is configured with this particular IP, for example 1.1.1.1, a person called Suresh is mapped. This particular firewall checks whether this Suresh is there in the firewall. Okay. So the firewall initially tries to figure out who sent this packet. It checks its cache to see if it is the source address is already linked to the known address or a user group, because what we used to do, we used to create Active Directory Windows Server, and this Active Directory is just mapped to the firewall. So in Active Directory, what we does, we usually create all the users and we create all the groups, and everything will be there in the Active Directory, and we will connect the Active Directory using the LDAP. We have a separate portion called LDAP. There we used to configure the AD credentials and everything. So once we done, the LDAP listings, whatever there, the user and everyone will be not migrated, it will be mapped to the firewall. So the firewall checks whether the particular user is already there configured in the AD. If it is not there, it will drop. Okay. So it will check the policies against the user and IP address. And the fourth one is application catch. So what this firewall usually checks in this, it will just ask whether I have sent this application signature before. So this is what the application catch. Okay, the firewall just tries to quickly identify the particular application. Okay, it checks the application catch based on the things like destination IP, destination port and protocol. We have studied about the app ID, right? So what the app ID does, it categorizes all the applications and it has signatures for it. So what this catch means, the app ID already has signatures and the signatures are catched in the firewall. So what this catch does, it just a quick check whether this particular application which is going through the firewall is as any signature, or it is yet to find a signature for it. Okay, it needs to classify the application here. And the fifth one is forwarding lookup. So in forwarding lookup, the firewall knows who and maybe what the packet is. Okay, it just need to figure out where it need to send it. This is called as forwarding lookup. Okay. So it has many features in it. In forwarding lookup we have L3 mode, which is called as routed mode. And we have layer 2 mode, something called as, which is switch mode. And we have something called as virtual wire. Sorry. And we have something called as tap. So yesterday we have discussed about all this. So in routed mode, what happens if the firewall interface is in L3 mode? What it does, it performs a route lookup table, okay, using fib, forwarding information base, to check its next stop of the packet. Okay, if the destination is on the same network, what it does, it does a ARP lookup to find the MAC address of the destination. Okay, sometimes there is a policy based forwarding rule, so which might override this feature. Okay, in routed mode we have a normal lookup and we have a policy based forwarding lookup. Okay, and this is the normal routing. So consider a source, this is the source and this is the destination and this is the firewall. So I am initiating, so this is a normal routing. Okay, the firewall does the normal routing here. It checks the source and destination, it has to be routed here for the particular destination. In policy based forwarding, what it does, consider you have two ISPs, one ISP here and another ISP is here, ISP1 and ISP2. So what happens, consider there are two networks, 1.1.1.0/24 and you have another network 2.2.2.0/24. So for this particular network, the normal routing will be going through the ISP1, and for this particular two network we have a policy based routing. So what this policy based routing does, it instructs the packet to forward it through the ISP2 instead of ISP1. Okay. And we have another mode called switched mode. So in this mode the firewall is acting like a switch. It just look up the outgoing interface for the destination MAC address, okay, in the MAC table. If it doesn't find it, what it does, it flets the frame, like what the switch does. It flets the frame out of all the interfaces, okay, just like a normal switch will do. And what is virtual wire? So in virtual wire, it's like a transparent connection. So no complex routing lookup is needed, it's just one end to another end. Okay, just it's a bridge, like a bridge mode. Like for example, take this is the firewall. What we does, we just bridge the packets, no lookup, no any firewall feature, no firewall features are used here. Okay, just a normal, it acts as a bridge. No firewall will happening, no firewall lookup will happen. All the kind of ingress, flow lookup, nothing is checked here, just it will allow the packet, that's all. That is what we called as transparent. And another one is tap. Tap means something, we say it is monitoring mode. In monitoring mode, what it does, it's similar to switch port monitoring. Okay, span. Yeah, it's something called as span. In routing and switching, Cisco routing and switching, we have something called as span. So in span, what it does is, So consider we have a switch and we have someone sitting here. Okay, he is a malicious user. He is malicious user, and he is doing some malicious things. He has some installed some software, and he is uploading or downloading some files which is against our company policies, but the company needs some kind of proof what this particular user is doing. In this case, what we will do, we will create a separate span port. What this span port does, so we used to tell this particular span port, what it does is, this particular tap interface, all the packets of the particular interface is also sent to this span port. So we'll be having a specialized software here. Okay, so this software will just analyze what this particular person is doing, because all the packets whatever he is sending, downloading, everything will be also sent to the our span interface for monitoring. So this is a similar way we use in the PaloAlto firewall, and that name is called as tap. So after now we have checked about the forwarding lookup, right? So after forwarding lookup, what we do NAT policy, we do a NAT policy lookup. Okay, so sixth is NAT policy lookup. So in this, what it says, do we need to change the addresses in the firewall? Okay, the firewall needs to check whether it has to NAT it, network address translation. Okay, so right after forwarding, what it does, the firewall checks the NAT. Okay, this happens only in layer 3 mode. Okay, we have seen so many modes above, like L3 mode, L2 mode, virtual wire, and tap mode. So this NAT happens only in the L3 mode, and sometimes it happens in virtual wire mode also. Okay, so NAT rules are applied to where it applied, so it applied to the original packet. Just a minute. Okay, we can use this NAT for changing the source IP, or we can do the NAT for changing the destination IP. So we can do two kinds of NAT. So we have static NAT, we have dynamic NAT, and we have NAT exception, something in Cisco ASA where we will not do any NAT. So it will just tell the firewall to just transfer the packets without do a NATing. Okay, so the NAT policy lookup means whether the particular client, if the client is sending some messages to the server, so consider this is the firewall, whether it needs to do a NATing of this particular source. Consider I am 111 and this is 4.2.2.2. Sorry, you can take it as 192.168.1 private IP, whether I need to change the private IP to public IP. So this will be taken care in the NAT policy lookup. Okay, so after the NAT policy lookup, the seventh is application lookup. So application lookup. So if the firewall has not identified the user yet and the user ID is enabled, for example the packet is going to a web server and it checks the captive portal policies. Okay, if the policy matches, the user might be redirected to a login page. This is how many public Wi-Fi networks work. Okay, so it will just trigger the captive portal. Okay, captive portal means it's like something called, we will discuss this later on. Okay, captive portal, so it's a big topic, we just don't want to get deviated, we'll just go with the flow. So another is eighth. So the eighth is the DOS protection policy. So we have already checked about the policy, right? DOS protection policy. So the firewall has some more advanced DOS protection policies. So these policies are applied to detect the large scale attacks. Okay, it can apply aggregate threshold like random early detection to discard the packets. So random early detection means, so consider I am getting the SYN packet, I am getting more number of SYN packets from the particular IP address. So what I does is I have defined a threshold for it. So like I can only receive some 100 SYN packets from a particular user. If I am getting more than 100 SYN packets, I need to block this address, because he may be doing some scanning or some kind of attacks, DOS attacks he might be, or distributed DOS, those kind of attacks he will be doing. So in those kind of policies we will be having in the DOS protection policy. And another one is the final one is security policy lookup. This is the policy everyone used to do in day by day. Okay, policy lookup. So this is the actual policy where we have defined whether this particular source is allowed to, for example, this is the source and this is the destination and this is the firewall. Okay, so I need to make sure that whether this particular source is allowed to initiate a connection. I may be either deny or I may either allow the traffic. So all these policies, deny policies and allow policies, are there in the security policy lookup. And by default in the security policy we have two default policies. One is intra-zone policy and another one is inter-zone policy. So these two policies are there in the firewall by default. So intra-zone means, so within particular zone, for example take we have 3 zones in the firewall like inside, outside and DMC, and we have something called as DMC zone. So intra-zone in the sense, whether between this intra-zone means whether within this inside zone we might be having so many subnets. For example we have let me briefly tell you. Okay, for example for intra-zone, this is for intra-zone. For intra-zone we will be having different subnets, right? For inside interface, for example take inside interface, we have so many subnets: 10.1.1.0/24, 10.1.2.0/24, 10.2.3. So there are so many interfaces. We sometimes what we does is we just need to block this particular IP address from communicating to this one. Okay, this is called as intra. So within a particular zone we are trying to block something. If you are trying to block something, that is called as intra-zone. What is called as inter-zone? Inter-zone means we have 3 interfaces. Sorry, oh my god, we have 3 zones, right? So inside zone, outside zone and DMC zone. So inter-zone means, so between the zones. So whether I need to allow any traffic between these 2 zones, it is called as interzone, and whether I need to allow or deny traffic between these 2 zones, this is called interzone. So I have 2 default policies called intrazone and interzone. Okay, this will be an interview question. And also the security policies are always processed from start to end, like first 2 3 4 5. If we have entries 1 2 3 4 5, it will first check the first rule, then second, then third, then fourth, then fifth. It will just check in the sequential order. Okay, and the final thing is 10th one. There are so many things. Okay, 10th one is session allocation. So here what happens, so all our checks are, so now checks are all completed. As I said previously, that is the last one. This is called as a section allocation. So all our checks in the slow path. So now what we are studying is slow path, correct? So all our checks in the slow path are passed right now. Now a particular flow has been passed, means a particular communication from the source to destination is checked by the firewall, and this is called a slow path. And now all the checks between the source and the destination is passed. Now what I have to do, I have to create a session. Okay, so that is called as a client to server session and server to client session. So these two sessions are what allowed at last, once all the above checks are passed. Okay, okay. So we have checked the, so this is the completion of the slow path. Now we are going to discuss about the fast path, correct? FASTPATH, fast path. So fast path is something, so now our packet is part of the existing session. This means that it gets to bypass almost all of the slow path and jump directly to the fast path. So this is super efficient because the firewall has already done all the session details and policy decisions are cached and it is kept in a separate session. So now on the fast path, the firewall performs the quick layer 2 and layer 4 processing. So it, for some reason the session state has changed, for example to discard or something has happened after the slow path has a session in it, so it has to drop the packet immediately. So for example, so now client to server communication has been successfully there in the session table because our slow path has been completed, right? Now what happens, slow path has been completed and the flow was already there in the session table. Now fast path is taking place. Now what happens if there in the fast path, sometimes there will be some errors in the protocol headers. So now what we will do, we have to drop the packet because in the middle of the session also we will be getting the malformed packets. In those kind of things we have to drop the packet. And in the fast path again, what it does, so it does the forwarding lookup. So still know where we are going. So even in the fast path, the firewall confirms the forwarding lookup for both the directions. Okay, if the route has somehow become unavailable due to some changes in the firewall, so while initiating a session, initiating the slow path, so already there is a communication and everything was there. Suddenly some admin, they have done, they have removed the particular route. Now the firewall doesn't know how to process the packet. So what happens, so in those kind of situations we have to drop the packet, okay, in the fast path. So in fast path also the forwarding lookup has to be done. Okay, so sometime, and After that, what happens? SSL proxy. So means if it is a SSL session and it needs a decryption, okay, the firewall unencrypts the traffic, so it look inside and apply the security inspection. Okay, and the next one is, so application. So we have seen already the application has been identified, right, using the app ID. So it takes a few packets to really know what the application is. The firewall will perform the app ID on the first path. Okay, this is a dynamic process, because so whenever a communication happens from this particular source to this particular destination, we have a firewall. So this is the first packet. The firewall cannot able to identify what kind of application this is, because this is just a single packet. So we need some more packets for the firewall to identify it correctly, whether the application has a signature, existing signature in the firewall, or it is a new kind of application. So to identify it, the firewall need some kind of time, some time it needs. Okay. So again, so we have checked about the app ID, right? App ID. So app ID, what it does? In app ID, it checks the application, correct? So many things it used to check. So like it used pattern matching for detecting this particular signature. Okay, it also does the security lookup policy with the particular application, whether it is allowed or not, because only the particular flow is allowed, it can able to recognize the signature, right? Because if something is dropped, we cannot able to identify what particular application has been dropped. And so after ingress checkup, what we have learned after ingress, first is ingress, then the flow lookup, then what else we have? Slow path, then fast path, then app ID, right? Slow path, fast path, app ID, what else? 1 2 3 4 5, correct? Is it correct, or I am missing something? Yeah, it's correct. So now we are going to study about the content ID. Okay, so content ID is the sixth one. Okay, so this is where the firewall puts the detective hat. It's like getting serious. Okay, so now the session was flagged for the content and threat detection. Okay, CTD. Here we also something called as single processing, single parallel processing. Now our packet goes through the deep inspection, and this happens because it has matched a security policy, and we have a security profile also applied. Right, in the security profile and the security policies, we have applied URL filtering policy and the security profiles, and everything will be applied inside the policies. So if it is applied, it has to go through the content ID. If nothing was there, security profiles was not there, means it will not check the content ID, because I have not applied any security profile. So it checks with the pattern matching, that is we called as CTD, content and threat detection. So it looks for any advanced threat intelligence. So it just scans the actual content of the packet for malware, virus, spyware, and command and control traffic and vulnerability exploits, and so many malicious activities are there. So everything was checked in the content ID. So this is very important in the PaloAlto firewall. Okay, so the PaloAlto protocol decoders are incredibly faster. They can detect any kind of application shift also, it can detect, and if any application shift is detected, it will just drop the packet. Okay, and it is also detecting so many kind of anomalies here in the content ID, because it is most important form of packet inspection. Okay, so in this content ID, so either it can drop the packet, or it can reset, it can send a reset to the client, or it can send a reset to the server, or it can reset both. Okay, you can send a reset to the client as well as the server, and it can alert. Alert means it will log the traffic. Okay, allow also, what it does, it will log the traffic. Okay, but most of the times we will not log this particular traffic, but just for some kind of troubleshooting we can do this. Okay, so here I just want to mention one thing. Drop means it will silently drop the packet. Okay, silently drop, so it will not create any logs. Okay, it will just drop the packet. Logs will be there, but it will not send any. Consider there is a communication between the client and the server. I am doing any kind of firewalling, so if it is dropping, it will not send any reply. It silently drops the packet. It will not send any reply to the client, so the client doesn't know whether it is dropping or getting who is there, whether it's a firewall or something else. Okay, and also what it does, so if the packet was decrypted by the SSL proxy, now it will be inspected, like, because the firewall has a choice. So it either re-encrypts the packet using its own certificate, or it will decrypt. So those kind of things will happen in the content inspection. So now we have completed this particular session. Now what happens? Now the 7th stage is the forwarding stage. Okay, forwarding stage. In the forwarding stage, what happens? This is where the actual packet forwarding will happen. So in packet forwarding, what happens, it will check for the routes, it will do a ARP checkup, right? Because I have to do a route checkup. If I have to do the route checkup, I have to definitely have to do the ARP checkup, and I have to do the fragmentation, and I have to apply the QoS policies, and I have to check how much MTU is allowed to send through that particular medium, right? So all these checks are done in the packet forwarding. And so I have a client packet which is coming. So I have three interfaces, one is inside, one is outside, and another one is also outside one. So I just want to know through which, so a packet comes, I just want to know through which egress packet. So ingress has come, so everything has been done. So ingress, flow lookup, slow path, fast path, then what else, app ID, content ID. Now forwarding is, we are doing the forwarding. Now I just want to know through which interface I need to forward. There are two interfaces. I have received the packet in this particular interface, I need to make sure to which interface. So for that I need to do route lookup, ARP checkup, and I need to apply the QoS policies, MTU, and I need to do the fragmentation, and after that I need to make sure to which interface I need to send. Either I need to send via this interface or this interface. So the egress needs to be determined here. So this is the total, what we have today seen is the total packet inspection. Everything we have covered in it, because I was not able to cover it in a single day yesterday because due to some time constraints, but now I have some time, so I have took this in a single class. So just go through all the notes. I am also sending the video, I am recording it, so we have so much information here. So if you have any doubts, you can also, we will have a doubt session tomorrow. In the doubt session you just let me know if you have any questions. We will see, there are so many notes out there, so you can refer to these notes, okay, if you have any doubts. So I have also recorded it, okay, and if possible I will try to record another video for day 2. Just I will stop this session right now.